Wankel rotary engine. This is made by Felix Wankel. It's made in 1957. This isn't your everyday engine. It's compact, high-revving, and a legend in its own right. Unlike boring piston engines, it turns explosions directly into rotation. Mazda made it famous in the RX series, making sports cars scream with joy. Some called it a risky experiment, but it became iconic for speed lovers. Imagine a triangle spinning inside an oval chamber. Yep, that's the magic. Each corner of the triangle compresses, ignites, and exhausts fuel in a smooth dance, producing power every single turn. Fewer parts, higher RPMs, and that addictive wail, pure adrenaline in an engine. H16 engine developed by Harry Westlake and built by BRM in the 1960s for Formula One. This engine was pure ambition. H16 tried to squeeze massive power into a small space by stacking two engines together. It did deliver big power and even won a Formula One race in 1966, but it was insanely heavy, complex, and unreliable. Engineers loved the idea, but mechanics hated it. Picture two flat-8 engines, one on top of the other. Each has its own crankshaft, and a central gear system combines their power into a single output. That means 16 cylinders firing in sync. Huge power, but also double the parts, double the weight, and double the chances of something going wrong. Free piston engine early versions were developed in the 1920s by Raul Pateras de Pescara, with later researches by companies like General Motors and Toyota. It's a highly unconventional engine design that removes the crankshaft entirely. It's mostly experimental and hasn't seen widespread use in cars, but it's gaining attention again for generators and hybrid systems due to its simplicity and efficiency potential. How does it work? Instead of converting motion into rotation like a normal engine, the piston moves freely back and forth inside the cylinder. Fuel ignites, the piston shoots outward, then air or another piston compresses it back, sending it the other way. This continuous back-and-forth motion doesn't spin anything, so instead, it's directly connected to a generator to produce electricity, fewer parts, less friction, and a completely different way of thinking about engines. Knocker engine. Built by Roots Group in the early 1950s for Commer trucks. This thing was straight-up mechanical insanity in a good way. A compact, lightweight diesel that punched way above its size. It powered trucks like the Commer TS3 truck and became famous for its loud, rapid-fire knocking sound, hence the nickname Knocker. It wasn't just experimental, it was actually successful in real-world use, but also kinda too unconventional for mass adoption later on. Here's where it gets wild. Instead of normal pistons with a cylinder head, this engine has two pistons per cylinder facing each other. No cylinder head at all. But instead of a normal setup, the motion gets transferred through rocker arms to a single crankshaft below. It's compact, aggressive, and brilliantly weird. Why it's crazy? No cylinder head, no valve, fewer failure points and better airflow efficiency. Opposed pistons equals insane power density. Opposed piston engine. First developed in the late 1800s, but it really took off in the 1930s with companies like Junkers and later Napier, refining it into powerful engines. This thing is one of the coolest, why isn't this everywhere, engines. It was actually very successful in aircraft, submarines, and military vehicles. Then it kinda disappeared, and now it's making a comeback, because it's insanely efficient, and modern engineers love it. All right, picture this. Instead of one piston in a cylinder, you've got two pistons facing each other, just like the Knocker engine. No cylinder head, no valves, just pure mechanical chaos in the best way possible. They move toward each other, compressing the air-fuel mix in the middle, boom, combustion happens, and both pistons get blasted outward. That means power on both sides. Double the action. Even crazier. Intake and exhaust ports are uncovered by the pistons themselves, so the engine breathes without traditional valves. Fewer parts, less heat loss, more efficiency. The catch, it's mechanically complex. Deltic engine. Developed by Napier and Son in the early 1950s, originally for high-speed naval boats. This thing looks like an engineering madness. 3 crankshafts, no cylinder heads, triangular layout. And yet it actually worked and powered fast patrol boats and even locomotives. It wasn't just experimental, it was wildly successful for its size and power. Imagine 3 straight engines arranged in a triangle. Now remove the cylinder heads and put pistons on both ends of each cylinder. That means 6 pistons per triangle side, all moving toward each other. As the pistons compress the air-fuel mix between them, it combusts and pushes them apart. Each corner has its own crankshaft, and all three are geared together. The result: ridiculous power density, screaming RPMs, and a mechanical symphony that sounds like a futuristic swarm of bees. It's basically a triangular two-stroke monster built purely for speed. Hootland's spherical engine, designed by Herbert Hootland in the 1990s, with working demonstration prototypes appearing in the early 2000s. This engine looks like it belongs in a sci-fi movie. Instead of rows of pistons, it's built around a compact spinning sphere. The Hootland spherical engine was experimental and never mass-produced, but it proved the concept could actually run. The big idea was fewer moving parts, smoother rotation, and a very compact design. It didn't replace traditional engines because it was complex to manufacture and hard to optimize, but mechanically. It's one of the coolest internal combustion concepts ever demonstrated. How does it work? Inside a spherical housing, several pistons are arranged radially, pointing toward the center. When fuel ignites, combustion pushes the pistons outward. The pistons slide along angled guide tracks. Those angled tracks convert motion directly into rotational motion, and the central assembly begins rotating smoothly. So instead of up and down pistons turning a crankshaft, it's explosion to sliding motion and to direct spherical rotation. The result: a balanced, continuously spinning engine that's compact, smooth, and visually hypnotic, like a mechanical gyroscope powered by explosions. D-cycle engine, developed by Mian Yan and his company Yan Engines in the 2010s. This engine looks like something straight out of sci-fi. Instead of a normal single piston, it uses a split, articulated piston system that completely changes how motion is transferred. It's still experimental, not mass-produced, but it's designed to boost efficiency, reduce friction losses. The piston motion isn't symmetrical anymore. Each stroke can be independently optimized. The linkage controls how fast and how far the piston moves at different points. So instead of the crankshaft dictating everything, the mechanism reshapes the entire cycle dynamically. Result: more control, potential efficiency gains, and a design that tries to squeeze more work out of every combustion event. 5-stroke engine, developed by Gerhard Schmitz in the 2000s with working prototypes demonstrated around 2009. At first glance, it sounds fake, 5 strokes, but it's real. This experimental engine was designed to improve fuel efficiency by extracting more energy from each combustion cycle. Instead of letting hot exhaust go to waste, it reuses that energy in a clever way. While it never became mainstream, it proved that traditional engine designs can still be pushed further. It doesn't use a single cylinder doing 5 steps. Instead, it uses 2 smaller cylinders and 1 larger cylinder. The small cylinders handle intake, compression, combustion, and the first expansion, similar to a normal engine. But instead of releasing the exhaust immediately, the hot gases are redirected into the larger third cylinder. There they expand again, creating a second power stroke, the 5th stroke. This setup extracts more energy from the same fuel, improving efficiency and reducing wasted heat, like getting a second push from the same explosion.